Hi, so today we are going to learn how to make a tetrahedron from a circle. I've got a circle cut out from a piece of paper and I've got my center point marked. First thing I need to do is I'm going to take any point along the edge of the circle and fold it so that it just barely touches the center of the circle. And I'm going to put in my crease. Then I'm going to do it again, but the next time I do it, again, I'm going to fold from a point on the center of the circle, or a point on the edge of the circle to the center point, but I want the end point of that next segment to be the same as the end point from the first segment. So the way I like to do it is, I like to finagle it kind of like I'm almost making a waffle cone, where I make sure that I get the end point first, and then I just kind of roll it until I get it to the right place so that I've got that, so that it touches the center of my circle. So it's going to look like this. Then I'm going to do it one more time, but this time the endpoints of the third segment are going to be the same as the endpoints of the first and second segments. And again, that point that's actually the center of the arc is going to come down and touch right there at the center of the circle. And if you've done it correctly, everything just feels like it falls into place. All right, so I've got this triangle, and it sure does look to me now like it is an equilateral triangle. But do you know that it is? That's a really cool exercise to do with your high school geometry students. If you look in here, you can see we've got congruent chords. How do we know they're congruent? That's a proof. So you can either do it with congruent chords and what that means about the arcs that they cut off, or you can do it as a special right triangle proof. There's a couple of ways to do it, and they're all just really, really cool. But once we know that this is an equilateral triangle, now we can do some neat things with it. First thing we're going to do is we're going to fold this point here so that it comes down and touches the midpoint of the opposite side of the triangle. And when we do that, if we do it well, looky there, we're going to end up with an isosceles trapezoid. But when we fold that flap down, it kind of looks like that is also an equilateral triangle, and it also kind of looks like it outlines two other equilateral triangles there. And what I'm going to do is I'm going to take those other two equilateral triangles and I'm going to fold them right over the top of the other one. And so now I've got this nice, beautiful, small equilateral triangle. And again, this is a neat thing that you can ask your students to justify. How do you know if the big one was equilateral? How do you know that this one is equilateral also? That's a neat proof. Okay, but once you get that, you'll notice that I've got these three flaps. 1, 2, 3. And if I fold those up and then bring them together, now I've got 4 congruent equilateral faces that are all connected. And that makes a platonic solid, which is the tetrahedron. So that is how you make a tetrahedron from a circle.